Well, I will check back anyway so we can get started in respect of the time. And I'm posting up here, and you'll see this on a slide coming up, that my blog address where I will be putting up any links after this talk is done so that you can follow up. Because we do have a lot of slides, and I'm going to go a little fast. If you have questions, feel free to put them up in the chat, and I'll try to find good stopping, come and talk things. And I would be remiss in not thanking Code PaLOUsa for having me and giving me the opportunity to rant a little bit about serverless functions, and also thank the sponsors for giving them the opportunity to give me that opportunity. For all you who don't know me, my name is Michael Meadows, and for those of you who do know me, you're probably thinking, hey, you're not from the South, and I just heard you say all y'all, which there's a fine line between cultural appropriation and pandering, and I'm pandering, so you can go cry into your bourbon and go watch a college basketball game or a horse race. So the link, again, in the chat and on this slide in the middle is where I will post any additional links, based on questions that are asked or just on the material. If you're looking for the direct link for the slides, you'll find it there as well. Little about myself: I work for Insight, which is specifically I work for the group within Insight. Companies kind of exist just to the left of the bleeding edge. Specifically, what I do is I help companies adopt new technologies in the cloud. I focus a lot on PaaS platforms, and I've done a lot of work with microservices and serverless functions as well. So this talk is really based on my experience with serverless functions, especially in helping companies kind of dig themselves out of the mess that they've made in their serverless adoption. So you think you can do serverless. Like I said, I may have a skewed view here because I usually get called in after things have gone south, and it's only after doing that a few times that I've actually started some greenfield serverless projects to varying degrees of success. But the lessons learned is really what's feeding this. And right now is usually when I get interactive and I ask people, who's done serverless. And a bunch of people will raise their hands, and then I'll say, if that serverless was AWS Lambda, put your hands down, and there'd be like 2 people with their hands left up, and then I'm like, if you've done Azure Functions, and they put their hands down, and nobody would be left, because even though GCP is actually a pretty good platform, nobody's used it. So idealistically, it just sounds great, right? And my peers have gone up in conferences like this, and told you all the reasons why serverless is the future. It's sort of the purest incarnation of building things in the cloud that you can get, right? I mean, you don't have to worry about infrastructure. It's small units of increment that can go basically up to infinity. This all sounds really great, right? And then when you're done, then you can put your own abstract together and talk at Code PaLOUsa next year. So it sounds great. And just strangers who you've never met before are just gonna love you. That one was a little bit of a flop, sorry. No, maybe not. So if you're among that group that would have raised your hand, there's a number of issues, and pretty much the euphoria of getting the thumbs up on doing a serverless project starts to evaporate right away. And although I have this list of issues up here, they're common things that people run across that start to jade them a little bit on the idea of serverless functions between the different platforms. And we're going to be talking about AWS Lambda, Azure Functions, and GCP Cloud Functions. There's varying degrees of bad in each of these things, but they're things that people generally tend not to think about when they jump into a serverless project that become problems primarily because they didn't think about it. So with that, I'm going to transition into the first part of this talk, which is really focused on helping you understand all of the problems that are associated with this. I'm going to go a little fast because I have 48 total slides here, and there are a lot of bullet points, and I don't want to sit here and read those bullet points for you. Again, if you see something that catches your eye, want me to explore a little deeper, just go ahead and throw that up in the chat, and I can try to answer those at a good breaking point. There is an ugly side to it, and I say this often that you can't eliminate complexity in any given system. The only thing you can do is move it around to where it makes sense, right? So for the simplicity of moving towards serverless, you have to take on a bit of complexity. And this next group of slides is not really meant to give you the solution. It's meant to point out what that complexity is, so that when I do give you the solutions, you can kind of understand it. So the first one is cold starts. So this is a problem that oftentimes people recognize early in a project, but don't really understand how bad it's going to be until they start getting ready for production. And the gist of it is this, that even though it's called serverless, there's still a server there. So if you think about this idea that you only pay for what you use, the cloud provider is going to aggressively scale down, so that if, let's say, your function hasn't been called for 5 minutes, you may scale down to 0 nodes for that particular function, which means that the next time it's invoked, you're going to have to wait for the runtime to come up. So in the case of, for example, AWS Lambda, it needs to build that image from the layers and then start it. And then B, you're going to have to wait for your function itself to start, which is why later on I'll recommend that you just stay away from compiled languages. Start is going to be a problem for you. Vendor lock-in. So this is another one that people find hard to accept at first. And the idea is that whether or not it's portable, there's going to be a framework that you have to use. There isn't, among the top 3, there is not a platform available that lets you pretend that there's no platform underneath. And what I mean by that is that a framework that you have to adopt in order to interact with that serverless platform. So, you're talking about like, or package import. That's sort of the first layer of the problem, right? When you dig a little deeper, you're gonna see that different platforms handle portability differently as well, right? So with Google and Azure, you have the ability to actually host this anywhere you want, although the benefits kind of evaporate because now you're actually managing the infrastructure as well. The question is why shouldn't you just make it a Kubernetes cluster, right? Configuration management is one that people tend to underestimate, but it's actually a pretty big issue, right? I mean, as with microservices, versioning becomes really important. But also with serverless functions, you have to consider that if you don't get on top of automation early on, the amount of complexity in managing your configurations is going to grow geometrically faster than the amount of business logic. Because as you add more functions, you add more functions to test versions of the management. And then there's people from a traditional monolith world really don't understand what the big deal is when I hammer on messaging. But you can think of how you would build something in a monolith. You have A call B, call C, call D, and then it saves the data, right? Well, in this case, if you think of a call chain, let's say arbitrarily 10, let's just make it nice and round and say it's 12 calls long, right? You make 12 service calls before you set transaction. And the cold start time on each of those is 10 seconds. and it just so happens that they've all scaled down to 0, you've added 2 minutes to that call chain. So basically what would have been a really simple, straightforward transaction in a monolith becomes a 2-minute wait in serverless functions. So understanding that and choosing the right type of messaging is actually more than just choosing how you deliver that message, but it's also understanding how you architect the functions themselves in order to work the best with method delivery that you choose. And we'll get into some deeper details there in the next section. And then there's state management. And this is one of those ones where I really don't know how, this is where I really wish I was down there with you guys, because, making no judgment on Governor Beshear, but this is sort of, I guess, supposed to be an inside joke. Get it, state management, governor. The fact that I had to explain that is, it just makes me feel all gross. Usually I tell a lot of jokes in my talks. Well, Rebecca. State management is also a really big deal. So if you think of the last scenario that I talked about, you did all these things and then you saved the data. Well, with serverless functions, that's not a very good idea, because what ends up happening is you are building a really inefficient chain of events that ends in a big data store. Find that your functionality with the functionality that you're expanding. You really need small and tight clusters of functions around specific entities, and then you actually need to build processes that keeps those entities consistent with each other. And the reason for this is that you don't have ACID, right? So you don't have ACID in your database, and you don't also have ACID between your services, right? And what I mean by that is there's no way to roll back, right? So if service A calls service B calls service C, which saves data, which calls service D and else, well, you either have to write the process that goes back and deletes the data that was saved in service C, or you think about it differently. And I'll kind of give you a solution later on. Incidentally, I do have a talk out there about, it's an intro to distributed architectures that I will throw in a link in that post or the link that I showed you there. Because that may actually help also put a little more text around what I mean when I say, call chain dependencies are bad, and you really have to account for the fact that you don't have ACID. And then there's telemetry. So what I will say is that regardless of which platform you choose, you will have really good built-in telemetry, but you want to take it a little bit further. So in addition to logging, you also want to monitor custom metrics. And the reason you want to do that is that you want to understand at a very detailed level how each function, and not just each function, but each version of the function is being used, so that you can understand the impact on a change that you're planning on making to that function. In this world, everything is loosely coupled. So if you don't have good telemetry, it's really hard to understand what's going to happen when you make a change to a individual function. How does that affect everything else down the line? So, you need custom metrics, which is something that you're going to have to think about as you're designing this, and then just really good logging, because you can't. It's hard to debug across functions. So the better your logging, and the better that they're correlated with each other, the better off you're going to be. Now, the real problem, though, I kind of talked about all these things to deal with, but the real problem is, and what that is, in general, the things that you've been taught about what constitutes good programming, that's wrong. And it's gonna, the hardest thing that I've had to deal with is I help companies come to grip with their serverless function adoption is actually just getting the people who are building this thing to understand that best practices in one thought process sometimes are counterproductive when you transport them into a different technology. So for developers, just as an example, when we read through these things, I'm sure most of the people attending are developers. When you read through these, they probably give you the warm fuzzies. You're like, oh yeah, this is my comfort. This is my grits. God, that was terrible. Comfort food, macaroni and cheese. Yeah, the thing is, all of these things are a bad idea, right? If you're talking about serverless functions, they really, really will kill you if you spend your time trying to make these things happen, because they either produce marginal value or they're literally counterproductive, right? And I'll get into why, but I want to understand that this is really important. And then because I'm still pandering, for you developers, that spells pizza. I don't know why that's pandering. And then we have our designers, and I love my designers. And if any of you in the room are designers, that white space on the right meant to provide contrast and draw your eyes towards the funnel on the left. And if I had a PBR, I'd pick it up and drink it right now. I do love my designers, but the problem that I have with them often is that they really don't like to be told that the technology is driving the solution. But in the case that you're building things in either microservices or serverless functions, they really do. And it's important to understand, not just why, but what they're driving you towards. What you don't want to do if you're rendering a screen is wait for 15 independent functions to return results to you. A, because it's synchronous, which is, again, it's a bad idea, and we'll talk a lot about why. But B, also because if you're aggregating them, you're just adding to the time, right? Basically, the one that takes the longest to return its result is how long it takes to render that screen. Rather, what you need to do is build it to be event-based so that you can compose your screen in such a way that each component is responsible for displaying data that comes from a particular function. And it's event-based in that you don't go data, you wait for that data to be given to you once you've rendered the screen for the first time. This allows for you to account for the fact that if we're doing this properly, cold starts aren't going to be a problem because everything works asynchronous. And in fact, when you make a single call, it's uploaded asynchronous as quickly as possible. And in the background, well, when that's done, it's got to let you know about it so that you can show those results on your screen. Not only that, you have to also design for eventual consistency because you have no other choice. So there are ways around this. You can actually build subsystems that live on top of your serverless functions and aggregates all that stuff and is kind of like a static view, a snapshot view to what's sitting behind it. But that really is just layering on more complexity, and you still can't avoid the fact that there's a delay between when you start something and when it finishes. So designers, I love you, but we really have to rethink this. All right, so I did just spend, what was that, 22 minutes, more or less, talking to you about why serverless functions are problematic. I do have some solutions for you. So let's just dive right into that. And as a warning, I'm about to show you 13 slides with lots and lots of bullets. Mind you, and in that middle link are links to slide deck that you can read it more carefully if you choose. And also any other links that might be helpful, especially related to questions. So the first and most important thing, I'm not going to hammer on it all the time. The one that I will is don't build frameworks for frameworks. And you'll see me reference that a lot, and that will be the last slide we have of these 13. But this is really important. Don't try to build anything beyond moderate complexity in serverless functions unless you've at least started on your DevOps journey. And when I'm talking about DevOps here, I'm not talking about, you know, a company slapping the name of their and the word DevOps. I'm actually talking about true DevOps adoption, where you assume that infrastructure and operations is actually part of the development cycle. And, you know, as I said earlier, you know, it's the driving force behind this is that if you do not automate at the front of the process, you become overwhelmed by the complexity of it. So, you know, again, you can adopt opportunistically. You can do some things, but don't try to build a complex app if you have not started at least DevOps. So the next one is start small and grow into it, right? Regardless of if you started the DevOps journey, you know, I've got 12 more slides of advice for you, right? And it's not realistic for most organizations to think that they can sort of incorporate all of those, especially since some of them are a change in ways of thinking, you know, as part of the build of some complex app, right? You really need to come up with a pragmatic plan that allows you to succeed over and over again with very opportunistic adoptions. And then, you know, as you get, let's say, 80% through with this transformation, you can start to actually plan on how to build a more complex app in your serverless functions. Consequence of not doing this is you have to learn everything the hard way in production. And generally speaking, what ends up being miss your deadlines, the business loses its appetite for what you're trying to accomplish because they, you know, before you told them that serverless was faster, and it actually ended up taking a lot longer, what they knew is that you delivered faster in your old monolith. So don't set yourself up to fail. Start small and grow into it. Take cold starts seriously. You know, I've mentioned this a couple times, and I'll mention it a couple more times after this. There is not a single server platform out, or there's not a single serverless function platform out there that eliminates the cold start problem. Azure does the best in that they actually give you a tier which is provisioned and not consumption. And that basically means that you're paying, you know, you could just pay to have a node, and you know, whether or not it's being used. And I'll talk a little bit more about that when we do the bake-off. But knowing that cold start is a problem, then you really have to consider that your first choice for designing anything should be asynchronous. It should be part of a message that does not require something to wait for it to finish, but instead is based on this idea that it gets work, you know, it processes that work as fast as it can in order, and then it then pushes that off to the next thing. And we'll talk a little more in detail when we get to state management about ways to that. But that, you know, from a function perspective, that's fundamentally it, and you want that. You want to repeat that, because if you follow this and you actually design for the eventual consistency that is a consequence of this, cold starts are no longer an issue. Now, eventually consistency becomes an issue. That's a whole different conversation. And there is good advice on how to design for eventual consistency. The advice for managing cold start is generally really bad. And when I say that, I'm talking about, you know, auto warming script. You know, I've come into a number of projects where they tried to solve it using auto warming scripts, and they're just not a good idea. Auto warming scripts for their functions has impacted that in the end they're really super glad they did it. In general, it's something we had to do. I wish there was a different solution, right? So it's better just to know that cold starts are there and design explicitly your architecture to handle that. Okay, so dry. This is another one where developers will balk, right? But I'm going to make this as clear as I can possibly make it. Dry is a trap. So the idea that you should repeat yourself works well in a monolith. Even then, I would say, like, if you repeat yourself twice, does it really merit building a framework? But with serverless functions, it's just a really bad idea. And when I get to my framework slide, I'll share one of the main reasons it's a bad idea. But the question that I would ask is, if your code is big enough that dry becomes an issue, maybe you should consider that your function might be too big. And that's a question you should always ask yourself. If I have to do work, maybe you'll find that the thing that you repeat the most is your bootstrapping code. And I've got a slide all in itself for bootstrapping. So we'll move to the next one, which is unit testing. So this is another one where I say that your functions should be small enough that you wouldn't need to unit test them. You should actually just contract test. And what I mean by contract test is you should write a functional test that wraps the input and the output of that function. Functions themselves need to be either idempotent or deterministic, basically meaning that in terms of deterministic, when I get the identical input, I will always produce the same output. Idempotent saying if I get this input multiple times, the side effect of the function itself will always produce the same result. It's a little bit different than determinism, in that determinism does not produce side effects at all, versus idempotency, where it just basically says, okay, look, if you give me the same transaction 4 times, I'm not going to process it 4 times. I'm only going to process it once. And I'll get into this a little bit more, why that's important. But based on that, it shouldn't be hard to test a function from the outside in. And there's a good reason to do it, which is that if you're going to deploy multiple versions of this function, you want to ensure that any change that you're making is back compatible and maintains the integrity of the function's contract to anything that is interacting with it. So again, version is going to crop up as a problem that you have to solve. Contract testing is going to help you with that. In addition to that, end-to-end testing is really important, because sometimes it's really hard to understand the impact of changing one function on a more complex workflow that uses that function. So end-to-end tests will help you with that. If you're doing state management right, it shouldn't be hard to substitute the backend data for an end-to-end test with your test data when you're doing it. So these are all things to consider. Again, for me, unit testing is a code smell. And if you start to feel it, if you start to smell that stink, you should stop and just ask yourself that question. All right, so monitoring. A lot of times, monitoring is something that you kind of worry about later. I did hit on there, so I'm not going to spend too much time here, but you really should think about what it means to monitor this thing as you're building it, because if you get into that practice, you can actually make sure that you're capturing what you need when you need it, so that you can analyze and better manage this environment, right? Because again, versus a monolith where you may have 2 or 3 or 4 things deployed and running. With functions, you're going to have hundreds, and if we talk about versioning those things, you may have several hundreds. So, the sooner and the better you get a handle on what that monitoring means to you, the easier it is going to be to maintain this thing when you get into production with it. All right, so reliable messaging. This is, functions exist in almost the purest space of a distributed environment. And what I mean by that is that you have all of these independent processes that sort of collaborate with each other, but don't really. And when we get into state management, I'll tell you what I mean by don't really, but they collaborate with each other via messaging. And so unlike with a monolith where, when A calls B calls C calls D, that's all within the same process. You can see it on the callback. They have access to everything within that process. You can use shared injected dependencies and libraries and functions, libraries and classes to share the context that they need to execute. With serverless functions, you have none of that. So, first of all, you need to understand what the demands are in a community to be in order to pick the right thing. But in general, you want to avoid synchronous calls, again because of the cold start problem, but also because it's even without cold starts, it's going to take a little bit of extra time to marshal that call as a service call. There are things like RPC, which is a binary protocol, which is way faster than things like REST. But even then, it's if you can avoid that and use an asynchronous technology, that's the better way to go. In order to go from a synchronous call, like let's say you have a gateway server that has a web endpoint to a queue, that's called asynchronous offloading. And generally what you do is you assign some sort of a correlation ID at that point, and then you return that to the caller so that they can call back and check if they want to know what the status of this thing is. Alternately, you can use streaming. So I'm thinking like websites or HTTP sockets to provide proactive notification back to your UI or to your application when this process completes. So there really is no one size. I mean, like understand messaging and how you would adopt best suit a particular state management. And this one was so important that I didn't give you a picture, right? So let me say this as clearly as I can. Don't use shared databases. And I even gave you a little asterisk here, right? It's just a bad idea. Don't do it. You'll regret it. I know some of you are thinking, well, he doesn't really mean it. I really mean it. Don't do it. You will regret it. And then there are going to be some of you who still don't believe me, and you're going to do it, and then later on you'll regret it, and then you can come back and watch the video of this and be like, oh man, I should have listened to you. The problem with sharing a database is basically having a centralized database rather than having your functions cluster around an entity. So you might have a function to create the entity or update the entity, and a function to get the entity, and that's it, right? Is how that entity is being used as you add more services to it, right? As you add more functions that consume that thing. And the problem with that is that you will find yourself in this morass where at some point you've seized up. You want to make a change to it, but every time you break something else. And at that point, your productivity just falls through the floor. You wish for death, and you go home crying every day. So avoid that at all costs. The other thing to consider is that if you think about offloading your transactions into a synchronous process, there's a couple problems that you run into. One isn't really related to the asynchronicity of it, and that's just the call dependency problem. So if A calls B, calls C, calls D, calls E, and each one of those has to do something, right? They have to create a side effect. So they're all acting on the same model, and they're manipulating them in subtle ways to the point where you get down to the final one, and how that data got manipulated on the way. And you as a developer won't know how it got manipulated on the way. And one of the consequences of this is that so shared understanding of that, it becomes really hard to change the model itself. And in addition to being hard to change the model, what ends up happening is people just add a property bag, right? A dictionary or a map in there, and then start stuffing properties in there so that somewhere down the line, something needs it, they grab it out. And before you know it, you just have this mega model that is, a few properties and then a giant dictionary of things that you don't know what they do, right? And that becomes a maintenance nightmare as well. So the right thing to do is to orchestrate this, to sort of flatten it out so that you have one service that calls service A and then gets the result, does something with that. Service B gets the result, does something with that, calls service C. And that's orchestrating these calls. Now, this is one place where I would say at least Google and AWS kind of fall flat. They offer PaaS services that do this for you, but they don't really give you anything within the framework itself to help you. Microsoft does it, but they really you sort of drink a cup of Kool-Aid to go down this road. But regardless, these processes, these orchestrations themselves are also stateful because they run over an extended period of time, and you don't want that process to open for that entire time. Because what happens if the node is deallocated, or what happens if it crashes, or any number of other possibilities. So they should manage their own state. And then I mentioned idempotency. I'll say it again. You do not have ACID. You should not assume you have ACID. You should not try to give yourself ACID. You are stuck in a world where that is not available to you. So how do you handle it? Well, you handle it with idempotency. So, there will be times with reliable messaging, especially queues, where you may have to read that message a second time. And what you don't want to do is build a lot of complexity in determining whether or not you should send that again. Just send it, right? And build your system so they're able to understand if they've already received and processed that message. If they have, they just ignore it. If they haven't, then they continue on, right? Designing them from the beginning will save you a lot of headaches. All right, and then there's versioning, and I've talked about this a little bit, but we'll do this a little bit more. Versioning your services is a really great way to support future what you build. And what I mean is, you not only do you get things like A/B testing, but you have the ability to roll out your changes and then gradually drain your old version and move all your transactions into the new one. In other words, let one complete all its things and then start sending a small portion and then a larger portion and then all of your incoming new traffic to the new service or the new version. This allows you to have a far better handle on your uptime. You can roll your deployments now as opposed to sort of expecting some sort of a switch, and it drags. You also want to version your data, something that developers have a really hard time with because they're not used to thinking this way, right? And what I mean by this is that when you need to make a change to your data model, you need to understand the impact for backward compatibility, but also forward compatibility. So if you roll out version 1.1 of this function, and it has a small change to your data model, you would understand that if version 1.1 is writing that data to a data store that is sharing with version 1.0, version 1.0 can still understand that data and not break it. But also version 1.0 can read data that version 1.1 is writing and still understand it and not break it. Or version 1.1, you know what I mean. So it's got to be backwards and forward compatible. And then you have to make it so that you can flip a switch to migrate the data from version 1.0 to 1.1. So when you're ready and you're confident that 1.1 is working right, you can tell 1.1 that hey, every time you encounter older data, run this code to migrate it to the newer data. And this is not a transparent process, right? This is something that you have to think about every time you change data into your data store. So as you do it more, it feels more natural. It doesn't hurt so much, but a lot of times for people at the beginning, this is really hard to accept. And then we have bootstrapping. So there is varying degrees amount of bootstrapping that you have to deal with, whether it's Lambda, Cloud Functions, or Azure Functions. And my advice to you is just don't avoid it, right? Don't try to framework away this problem. It is what it is. You really should be treating your code as if it's disposable. So if you have new bootstrapping code, you should be able to just copy and paste your business logic into a new template and then deploy that as the next version. It sounds weird, and people are very against it usually the first time they hear it, but doing this will make things much easier for you than frameworkifying this solution. Don't build apps. So the title of this thing, I know it says serverless apps in it. And maybe this is a little inflammatory because I do think that you can build apps with serverless functions. But just like I said, with start small, you don't want to set yourself up to fail. There's a lot that you have to learn if you want to build as complex as a real application entirely in serverless functions. And until you are comfortable building things in the way that functions kind of demand, if you try to build an app, you're really going to spend more time wrestling with the technology than solving business problems. And it's going to invalidate the case that you made for building this in serverless functions in the first place. So avoid it until you are really good at this thing, right? You gotta crawl before you can walk. All right, and always use bindings. So this one was a tough slide for me because every platform calls it something different. But regardless of what they call it, your cloud function frameworks, or sorry, your serverless function frameworks are going to provide you the ability to sort of automatically wire up your triggers and in some cases your outputs. And you know, even if you really like that library that you have for, say, example, saving data to your favorite SQL database, you know, we really love this ORM. My advice to you is, as much as you love it, if you let it go, because you have to deal with a lot of BS when not a platform. You want to, if it's going to do you any favors, you want to take advantage of those favors. Don't turn your back on those favors, because then you're really, all you're doing is embracing all of the things that suck about it, and you're kind of turning your back on all the things that might make it nice. So, you know, give it a try. You know, make the best of it. I've seen some really weird things where, you know, for example, let's talk about Lambda. You know, Lambda lets you save to DynamoDB with almost no code, right? And you know, I've seen people write their own frameworks over the Lambda SDK or over the DynamoDB SDK so that they could save in a way they like. Well, you know, what they're doing is they're bringing in this framework, which adds more code, which adds more startup time, which adds more configuration, to do something in more steps than if they just use what the framework gave them. And you know, when you ask, just like, well, I'm comfortable with this. Don't do something just because you were comfortable with it. And that is not my last rant on frameworks, because this slide also does not have any pictures. Look, don't try to framework away the underlying framework with your own framework, or I will personally hit you in the framework with another framework. People who know me know I kind of have a problem with framework writers, whether they're writing a framework for shared use, or especially if they're writing framework for their own team. And the reason I do is that every time you write a framework, what you're doing is harder to get to the core of what it is that you're trying to solve. You know, it may seem by writing a framework, but the honest to God truth is, if you are writing a serverless function and you need a framework for it, then you've made it too complex, right? The whole point is that the business logic portion of the serverless function should be, you should be able to reason about that thing by looking at it within a few minutes. And if it takes a new programmer fresh out of college who's never seen your code before any longer than an hour to tell you how to make any change to that serverless function, then it's too complicated, right? You know, set aside the bootstrapping. The business logic itself does not deserve framework. And then when we start to talk about the bootstrapping, it certainly doesn't deserve framework for all the reasons I've said. You actually also want your developers to understand very deeply how these things are configured, because more than 50% of problem solving with serverless functions is technical. It's about how this thing was configured, not about the business logic itself. So if the further from how it's actually configured, how it demands to be configured, the fewer people you have who can actually troubleshoot. So just don't do it. Just don't build frameworks. If you are trying to handle a dry problem, also don't do it with frameworks. Package a real thing. I've seen this a number of times, especially in microservice projects, where you build these frameworks that wrap frameworks, and before you know it, you can't update anything, because if you do, it breaks other things, right? So shell is real. Know that it exists. Don't regret it by pretending I didn't say this and putting yourselves in package hell anyways. I could probably talk for an hour about frameworks, so that is what it is. But it's time for the bake-off, or the Great Southern Baking Show. So, I put the three up here. I put them side by side, and I'm going to go pretty fast here because we've got 10 minutes left, and I do want to set aside some time for questions. Notably absent from GCP.NET or .core, my favorite development platform. Customizability, AWS, as usual, is customizable, and that comes at the cost of also being super complex. If you like making easy things hard, you will definitely like AWS. Azure and GCP sort of are all in on the whole serverless thought process. They're not customizable at all. Bindings, Azure is a clear winner here, but in a lot of ways it's because Azure Functions is more like an app dev platform. It's a really good SDK that is, if you dig just one level down, is actually really just on their app hosting platform, not on a custom-built serverless platform. So that is what it is. Monitoring, they all have turnkey monitoring with their respective platforms. Azure and GCP give you different ways to export. AWS a lot harder. Efficient AWS, once again, wins if you like complexity. GCP wins if you like CLI, and Azure, I don't really have anything good to say. Lockin. So GCP and Azure are pretty much on parity here. They both have OSS runtimes. They're portable. You can debug locally. You can host on your own platform if you choose. And AWS, AWS is what they are. Cold starts, GCP, you can't really do anything about it. Maybe that's for the best. Azure actually has a premium SKU that allows you to move from consumption to print. It's actually pretty good. Incidentally, it's the only way to get network integration in Azure. And then AWS, if you tried provision concurrency in AWS, I'd really be interested in knowing. The pricing is so prohibitively bad on it that I don't know how it makes anybody. And then if you're going to ask me to pick, I would probably give you a consultant answer. Let's see. I'll joke here. This is my favorite consultant joke, and as a lifelong consultant, I feel empowered to tell this. A consultant's driving down a country road and comes across a sheep farmer. He's feeling generous, so he hops out of his car and makes an offer to the sheep farmer. He says, "Hey, sir, I'll make a deal with you. If I can tell you how many sheep you have, you let me take one of your sheep." And the sheep farmer says, he looks at the consultant, and he's kind of feeling generous because, after all, he makes most of his money leasing his land out to natural gas frackers. He says, "Okay, I'll bite." The consultant then quickly pulls out his phone, calls 4 of his colleagues. They fly over and start this process where they work out what the QA is going to be, and how many times they have to count the sheep, what constitutes a sheep, what's the Six Sigma process for validating that. And several weeks later, the consultant comes back, hops out of his car, hands over a 138-page report to the farmer, and he's like, well, here you go. Farmer looks at him sheepishly, pun may be intended, and starts flipping through the 138-page report to page 15, finds the one number that's the answer, and closes the report, gives the consultant a good look, and he's like, well, sir, you got it right, so I guess I owe you a sheep. The consultant smiles kind of a little bit superiorly, picks up an animal and starts to walk. The farmer stops him. He's like, hold on, sir. I'll make a deal with you. If I can tell you what your job is in one try, you give me my animal back. The consultant's feeling a little generous because, after all, he doesn't really know what to do with his sheep. He's like, okay. And because you're a consultant. And the consultant is amazed, right? He's like, well, how did he get that in one try? So he says, well, how did you know that? And the farmer, puts down the report and says, well, you come busting in here with your fancy car and your fancy boots and your fancy pants and your fancy shirt, and you offer to tell me something, or you offer to give me an answer I already knew to a question I didn't ask. And after 3 weeks, you give me a 138-page report with the answer on page 15. And it's obvious as you're walking away with my animal that you have no idea what you're doing. So if you wouldn't mind, sir, I'd like to have my dog back. And see, this is the peril of telling a joke. Sorry. I'm hoping that you guys are laughing, but I'll move on to the next just in case you're not. All right, so Google Cloud Functions. Here's my opinion. Google Cloud Functions is the best all around. So it's really not the super best at anything, but it knows what it is. It's a serverless platform, and it's not gonna beat around the bush. It's not gonna try to be any. It's not going to be. It's not going to fail at being what it is. It just is. It is what it is. It's 3 stars. Azure Functions, and what I mean by the bones of a dinosaur here is, if you used Azure App Services, Azure Functions is just built on top of the Web Jobs framework for Azure App Services. Azure App Services is a serverless platform. It is a hosting platform for traditional apps. Now, they do charge you for consumption if you want to save money, but it isn't what it is, right? It tries to hide that from you, but it's not a serverless platform, but it does have a really good SDK. So I give it 2 stars, right? And especially when you consider durable functions and durable entities, those are really, they have some fragility problems when it comes to upgrading because of the way that they save their state, but they're actually kind of nice. And then we have AWS Lambda, and with respect to Lambda's cousin, is a sponsor of this talk. No stars. No stars. I have not come across a Lambda project of any complexity where we're glad in the end that that's what they adopted. So, if you want to share with me, I did Lambda and it was really great and I would do it again story, I'd love to hear it. But there's just so much complexity with Lambda that you actually find that you've just gone with traditional infrastructure. I mean, honestly, EC2 instances would be easier to manage than all of the versions and alias of Lambda functions that you end up putting out there. So that's the end, and I want to once again thank Code PaLOusa and the sponsors. And we've got only 3 minutes left for questions, but I'd love to hear them if you got them. All right, well, feel free again to I do have a website, but I don't update it often. Every year I commit to trying harder and don't, but I would welcome anyone here, and I'll even put my email out here if you've got questions. We'll